In this video, we will be looking at future value annuities. And before I show you the formula, I'm going to do a little example just to show you what an annuity is and where the formula comes from. So, Miss Carrie Annie plans on depositing $1,000 in her account at the end of each year. If this account earns 4% per annum compounded annually, how much will she have in her account after 5 years? Looking at this, you might think it's a regular compound interest scenario, but the key word here is that I am depositing $1,000 in my account each year. So it's not a one-time deposit. And that is really the main difference between an annuity and regular compound interest. The fact that you are adding money into your account at regular intervals. So if we just look at this little timeline here, in the first year, I invest $1,000 at the end of the year. This amount of money will earn interest. It will earn interest for 4 years, from 1 to 2, 2 to 3, 3 to 4, 4 to 5. So here is the formula, just regular compound interest. That first deposit gets $1,000 times 1 plus 0.04 to the power of 4 because it earns interest for 4 years. But the deposit that I add in the second year, it's only going for 1, 2, 3 years of interest. So here is its formula. That second deposit will be worth $1,124 versus the first year, because it was invested for a longer period of time, it got a bit of extra interest. Then in the third year, I'm only getting money or interest added for 2 years. So my exponent is different. In the fourth year, I just get money or interest added for 1 additional year. And finally, in the last year when I deposit money, it earns no interest. So at the end, the amount of money I have in my account is the $1,000 that I invested in the last year, the $1,040 from the fourth year, $1,081, 1,124, and the 1,169 from the very first investment. And if I add all of those numbers, my investment will be worth $5,416.32. Now notice I put 5 deposits of $500. So I only invested $5,000, but in total, I made about $416 in interest. And in this scenario, maybe you might say, well, why don't you just invest money, a lot of money at once, and then it'll grow more? But maybe, you take your savings and you invest a little bit each month or each year, whatever you'd like. Now, what I want you to notice about these numbers that I added up is to go from 1,000 to 1,040. All that happened, even looking at the formulas, is that we multiplied by 1.04. And then from 1,040 to the next one, again, multiply by 1.04. And I know I'm multiplying by 1.04 because my exponent just gets 1 larger, which means to go from one number to the other, I just multiplied by that interest rate, that 1.04, which should make you think of a geometric sequence. So the first number in this sequence is 1,000. Which is what I'm depositing each year. And then my common ratio is the amount of interest I earn for each compounding period. And this scenario, it's annually. That's why it's just 1 plus 0.04. But remember, if it were semi-annually, I'd have to divide the interest in half. So let's look at our general geometric series formula and fill in our interest information. So here is your series formula. A is your first term, R is your common ratio, but for us, our first term is R, those regular deposits. And then our common ratio is 1 plus I, so it has to get replaced 2 times. And if you look at my next equation here, you will see that I filled in the gaps. I put the R in for A, the 1 plus I, and in that denominator, you can see 1 subtract 1, which is just 0. So this is our final simplified equation for future value. Now, I just wanted to show you the connection between geometric and future value. annuities and how the formula came to be. So now let's actually apply it. In the first example, understanding the value of investing early, you decide to invest $1,000 into a tax-free savings account at the end of each year for 10 years. Here's the clue that it's an annuity. You are investing money at the end of each year. It's not a one-time thing, it's multiple times. If the tax-free savings account interest is 6% per year and it is compounded annually, what will the value be after 10 years? So let's write down everything we have. My regular deposits, that's $1,000. My interest per compounding period, so remember we take our interest and divide by the number of compounding periods, which is just 1 for annually. That's just 0.06. And the number of compounding periods is the number of years times the compounding type. So annually means 1. That is 10 in total. So now we can put this into our future value formula. So R 1 plus I to the power of n subtract 1 all over I. Let's fill in the blanks here. So our regular deposits is 1,000. We have 1 plus 0.06, and if you want to simplify that to 1.06 right away, that's fine. To the power of 10, subtract 1, all over I, which is 0.06. And now you can go to your calculator, plug this all in at once. So I recommend you pause the video and actually try to plug this in just to make sure you don't have any calculator issues. And hopefully you get approximately $13,180.79. And I didn't say how to round, but it's money, so we must know that it is 2 decimal places. And if I wanted to figure out how much interest was earned, I could just figure out the number of deposits. So I have 10 deposits in total, and each one was $1,000. So that's $10,000 that at the end of the 10 years, this is how much I actually put in. To figure out my interest, I could just subtract the future value, subtract my deposits. So I ended up making about $3,180.79. And then we could write a therefore statement, but I've just run out of space. So therefore, after 10 years, the tax-free savings account will be worth $13,180.79. So let's try the next one. After seeing the success of your tax-free savings account investment, you decide to open another investment account, and this time you put $500 into the account every 3 months at a rate of 5.2% per annum, compounded quarterly. How much money will be in the account after 25 years? So the fact that I'm depositing money every 3 months, that's the clue that it's an annuity, not just regular compound interest. And it says every 3 months. So if I take 12 months in a year and divide it by 3, that's 4 times a year, which matches the quarterly compounding period. And those will always match. So let's write down what we have. We know our regular deposits, $500. The interest per compounding period, we're going to take 0.052 and divide it by 4. And this actually gives us a nice decimal, so we can write it. But if that decimal went on forever and you would be cutting decimals, just keep that fraction. And we have 20 years and compounding 4 times a year. So that's 100 in total. And now that we have everything, we can go to our formula. So why don't you pause the video and try to plug it into the formula yourself. Plug it into your calculator, see how it goes. And if you want, you can also calculate how much interest was earned on this investment and then come back to the video and see how you did. So again, I am just writing the general formula here. So $500 deposits, 1 plus 0.013. The most common mistake is that people write 0.052, so be careful with that because it's compounded quarterly. and it's to the power of 100, subtract 1, 0.013 in the denominator. And then you go to your calculator, and hopefully you got approximately $101,487.91. And then I can write my therefore statement. I think I can fit it this time. Therefore, the tax-free savings account will be worth $101,487.91. And if I wanted to calculate the interest earned, first I'll figure out how much was deposited. So $500. And how many deposits did we have? 100, because it was 25 years, 4 times a year. So that means I deposited, or whoever this was, deposited $50,000. And look at that. You more than doubled your money. Now, this percentage isn't very realistic. It would be lower, but still, you can still get a good amount of interest. So when we subtract the two numbers, we end up with $51,487.91 in interest. All right, final question. With all of your newly acquired investment knowledge, you make a wise choice and decide that you'd like to build up a nice safety net for your retirement. So we want $500,000. Luckily, you found an account that guarantees an interest rate of 9.6% per annum that compounds monthly. To meet your retirement goal in 25 years, how much money do you need to deposit into the account each month? So I know this is an annuity question because I see the word deposit, but unlike the other ones, they tell me the end goal. They tell me the future value, and instead they don't tell me the regular deposits. So normally I would say start with R, but I don't know what it is. I do know that for my interest, it's 0.096 divided by 12, because this is monthly. That actually simplifies to 0.08. And then for N, we have 25 years of depositing money, and it's monthly, so I'll multiply it by 12. So that's 300 deposits that you make in total. And that 500,000 is the future value. So I'm going to write my general formula here. And I'm just writing it so that when I plug stuff in, I don't make a silly mistake. So I'm given the future value. So normally I would keep that FV, but I know what the future value is. I don't know the deposits, but the rest I do know. And you know what? This time I will just write 1.0. I'm just going to add the numbers. 1 plus 0.08 to the power of 300, subtract 1, all over 0.08. Okay, now what I personally would do, although there's 2 different ways you can do this, I like to put this over 1 and do a quick cross multiplying. That way I get rid of my fractions. So when I multiply this whole thing by 1, nothing happens. What does change here is I'm multiplying 500,000 by 0.08 to get 4,000. So 4,000 equals the rest of that number. And now I need to isolate for R. This whole section is going to be some sort of number. I don't want to turn it into a decimal because I lose accuracy. So I'm just going to divide both sides by that entire giant bracket. And that way these cancel out, but whatever I do to one side, I must do to the other side. So try plugging this into your calculator. 4,000 divided by, put your brackets, 1.008 to the power of 300 minus 1, close bracket, and make sure you get what I get next, which is R is approximately $403.29. Therefore, you must deposit $403.29 each month. So those are your future value annuities. You are depositing money into your account each month, each year, whatever, so that your account grows with time. Each deposit gets interest added on, some of them at different years or different time amounts. But the main difference, like I said, when you see that you're making this deposit at regular intervals instead of a one-time thing, you know it's an annuity.